Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring factoring by grouping. Before we get into the factoring by grouping, though, I want to review how to multiply two polynomials using double distribution. So in problem A, we have 3x plus 2 times the quantity 2x minus 5. So to use double distribution, you're going to take the first term of the first binomial, which is 3x, and you're going to multiply it by the second binomial, which is 2x minus 5. Then you're going to take your second term of that first binomial, which is positive 2, and you're going to multiply it by the second binomial, which is 2x minus 5. So what we're doing here is we're doing the distributive property twice, once with the 3x and once with the 2. So 3x times 2x would give you 6x squared. And 3x times negative 5 would give you negative 15x. Now I'll do the same thing in my second polynomial. I have 2 times 2x gives me 4x, and 2 times negative 5 gives me negative 10. Excuse me. To write your final answer, simply combine any like terms. So I'll have 6x squared. Negative 15x plus 4x gives me negative 11x. And then minus 10. So our final answer is going to look something like this. All right, pause the video and try problem B on your own. All right, welcome back. Let's see how you did. I took the 2x and multiplied it by the quantity 4x minus 1. Then I took the negative 3 and multiplied it by the quantity 4x minus 1. And that gave me 8x squared minus 2x. Negative 3 times 4x was negative 12x, and negative 3 times negative 1 was positive 3. So my final answer would be 8x squared minus 14x plus 3. Now, in today's lesson, we're going to be factoring polynomials with 4 terms. So what we're going to be factoring is problems like this, something with 4 terms. And to factor it means to rewrite it as the product of two binomials. So our final answer will look something like this. So it's like we're working backwards compared to multiplication, all right? Now, this will make a lot more sense after you see a few examples. But let's start with the steps, all right? To factor by grouping, the first thing you want to do is group the 4 terms into 2 pairs and look for a common factor when grouping. The second thing you want to do is factor out the GCF from each group. And step 3, you'll rewrite the polynomial in factored form by factoring out the common binomial. Now, I think when you see these steps in action, they'll make a lot more sense. So in example 2, it says factor each of the following by grouping. And I want you to notice that we have 4 terms, 6x squared plus 9x plus 4x plus 6. So what I'm going to do is I'm going to group these first 2 terms together and notice that the common factor is 3x. And then I'm going to group the second 2 terms together and notice that the common factor is 2. So I will rewrite this expression. If I take 3x and I take 6x squared and divide it by 3x, that would give me 2x. And if I take 9x and divide it by 3x, that would give me plus 3. And then my second one, we have a common factor of 2. So 4x divided by 2 is 2x. And then 6 divided by 2 is 3. Now, when you get to this step, you should have a common binomial. That's the greatest common factor. So we're going to, let me write that down. Our final answer will be the product of the greatest common binomial factor and another binomial. So to figure out the other binomial, I'm just going to divide each of these by the greatest common factor. So divide each term by 2x plus 3. And when I do that, this divides to 1 and this divides to 1. And we're left with 3x plus 2. So this is our final answer. So we started with an expression that looked like this, 4 terms, and we ended up with an expression that looked like this. All right, let's go through those steps again. All right, in problem B, we have 12y squared minus 8y plus 3y minus 2. So I'm going to group up these two terms and these two terms, all right? So my greatest common factor of my first two terms would be 4y, and the only thing the second two terms have in common is a 1. So when I divide out the greatest common factor, 12y squared divided by 4y gives me 3y. Negative 8y divided by 4y gives me minus 2. All right, and then put your second common factor, which was 1. So 3y divided by 1 is still 3y, and negative 2 divided by 1 is minus 2. Now identify your common binomial factor. So that will always be the first part of your answer. Okay. Now divide each term by the greatest common factor here. So our greatest common factor is 3y minus 2. So I'll divide each term by our greatest common factor. So that divides to 1, and this divides to 1. And I'm left with 4y plus 1. All right. Problem C. We have 8x squared plus 2x minus 12x minus 3. So here's a group, and here's a group. Now, my greatest common factor of 8x squared and 2x is simply 2x. My greatest common factor of negative 12x minus 3. Now, because that 12x is negative, I want to make my greatest common factor negative 3. Whenever this term here is negative, make your GCF negative. All right. So I will take and divide the first two terms by 2x. So 8x squared divided by 2x is 4x. 2x divided by 2x is 1. Or my second greatest common factor was negative 3. So negative 12x divided by negative 3 is positive 4x. And negative 3 divided by negative 3 is positive 1. So our greatest common binomial factor is 4x plus 1. Now, if I divide both those terms by 4x plus 1, what would be left over is just the 2x and the minus 3. So that would be our second binomial. Now, you could also write the answer as 2x minus 3 times 4x plus 1. These two answers are the same. It does not matter which binomial you write down first. All right. Problem D, 16r squared minus 24r minus 14r plus 21. So I'm going to group up the first two and group up the last two. So the greatest common factor of 16r squared minus 24r. Now, a lot of students think the greatest common factor here is 4r. But there's actually a bigger common factor, and that would be 8r. All right. The greatest common factor of 14r and 21 is 7. But because this term is negative, we're going to make the greatest common factor negative 7. All right, so let's take our first two terms and divide them by 8r. So 16r squared divided by 8r is 2r. And negative 24r divided by 8r is minus 3. Now put our second common factor, which is negative 7. Negative 14r divided by negative 7 is positive 2r. 21 divided by negative 7 is negative 3. So our common binomial is 2r minus 3, and our leftovers here is 8r minus 7. So that's what would make up our second binomial. Again, it doesn't matter which of these two binomials you write down first, as long as they're both there. All right. Now, let's talk about in our next example, what if there's more than one variable? So look at example 3a. Factor each of the following by grouping. And we have 8x squared plus 8xy plus 7xy plus 7y squared. So I'll start it the same way. And I'll just identify the greatest common factor for each pair. So my greatest common factor of 8x squared and 8xy is simply 8x. My greatest common factor is 7xy plus 7y squared is simply 7y. So my GCF, my first GCF is 8x. 8x squared divided by 8x is just x. 8xy divided by 8x is just y. So this is x plus y. Over here, my second greatest common factor was 7y. So 7xy divided by 7y is just x. And 7y squared divided by 7y is y. So my common binomial is x plus y. And then I want to write down my leftovers in the second binomial. So 8x plus 7y. All right, problem B. 12a squared minus 15ab minus 16a plus 20b. So I'm going to group these into two pairs and then identify the greatest common factor for each pair. So the greatest common factor for 12a squared minus 15ab is 3a. The greatest common factor for 16a and 20b is 4, but because this term is negative, I need to use a negative 4. All right, so let's take our first GCF and divide our first pair by 3a. So 12a squared divided by 3a gives me 4a. And negative 15ab divided by 3a gives me negative 5b. My second common factor is negative 4. So negative 16a divided by negative 4 is positive 4a. 20b divided by negative 4 is negative 5b. So my greatest common binomial factor is 4a minus 5b. And then my leftovers here are 3a minus 4. All right, problem C. A squared b plus a squared minus 8b squared minus 8b. So I'll group these up. My greatest common factor of the first two would be a squared. My greatest common factor of the second two would be negative 8b. All right, so a squared. So a squared b divided by a squared is just b. And a squared divided by a squared is 1. And write down your second common factor, which is negative 8b. Negative 8b squared divided by negative 8b is just b. And negative 8b divided by negative 8b is positive 1. So my greatest common binomial factor is b plus 1. And the leftovers would be a squared minus 8b. All right, pause the video and try problem D on your own. All right, welcome back. Let's see how you did. I used 5x as my greatest common factor for the first pair, and I used negative 4 as my greatest common factor of the second pair. So 5x, parenthesis, 10xz divided by 5x would be 2z. And 5x divided by 5x is positive 1. A lot of people forget that 1. They think 5x divided by 5x is nothing. But anything divided by itself is 1. So make sure you have a 1 there. Okay. My second greatest common factor was negative 4. So negative 8z divided by negative 4 is 2z. And negative 4 divided by negative 4 is positive 1. So my greatest binomial factor was 2z plus 1. And then my leftovers were 5x minus 4. And that concludes today's lesson, Factoring by Grouping.